Ramesh HG, working as Assistant Professor of Mathematics, Government First State College, Tiptur, Tumkur District. Today I am going to explain the concept of differentiation and related problems. Differentiability of a function. A function f of x is said to be differentiable at x equal to c if and only if both left hand and right hand derivative exist and they must be equal. So a function is said to be differentiable at a point x equal to c if both left hand derivative and right hand derivative exist and they are equal. Otherwise, the function is called not differentiable. So, here the meaning of left hand derivative and right hand derivative you have to discuss. So, let left hand derivative is f of x is a function which is defined in a comma b, then limit extends to c minus f of x minus f of c divided by x minus c exists. And similarly, right hand derivative limit extends to c plus f of x minus f of c divided by x minus c exists. Left hand derivative is denoted by L f dash f c. Right hand derivative is denoted by L R f dash f c. So if both exist, then we call the function is differentiable at x equal to c. If the both derivative exist but not equal, then the function is called not differentiable at x equal to c. Suppose if left hand derivative is 5, right hand derivative is 10, both exist but not equal, then the function is not differentiable. If left hand derivative is 10, right hand derivative is 10, both exist and both equal, then we say the function f of x is differentiable. If left hand derivative is 10, right hand derivative is minus 10, so both exist but both are not equal, then the function is not differentiable at the point x equal to c. So here prove that f of x equal to x sin 1 by x when x is not equal to 0 and 0 when x equal to 0 is not differentiable at x equal to 0. So you observe that left hand derivative is this is does not exist. Since left hand derivative is limit h tends to 0 minus sin of 1 by h, so it does not exist. And you see right hand derivative, so limit h tends to 0 sin of 1 by h does not exist. Therefore, the function is not differentiable at x equal to 0. The function is not differentiable at x equal to 0. So, both does not exist and both not equal also, both does not here, both does not exist, and hence the function is not differentiable at x equal to 0. Show that the function f of x equal to x square sin of 1 by x when x is not equal to 0 and 0 when x equal to 0 is differentiable. Examine whether the function f of x is differentiable at x equal to 0. So you observe that the function left hand derivative is this is 0, left hand derivative is 0 and right hand derivative is this is also 0. Left hand derivative is 0, right hand derivative is 0 and hence the function is differentiable at x equal to 0. So here you see that 0 into finite value between minus 1 and plus 1. Here also 0 into finite value between minus 1 and plus 1. Both exist, both are equal to 0 and hence the function is differentiable at x equal to 0. Discuss the continuity and differentiability of the function f of x equal to modulus of x at x equal to 0. So you observe that the function is left hand derivative is minus 1 and right hand derivative is 1. Left hand derivative is minus 1 and right hand derivative is 1, and hence the limit exists, left hand derivative exists, right hand derivative exists, but they are so the function left hand derivative is minus 1, right hand derivative is 1. Therefore left hand derivative is not equal to right hand derivative, and hence the function is not differentiable at x equal to 0. Discuss the continuity and differentiability of the function f of x equal to x when x is in between 0 and 1, 2x minus 1 when x is greater than 1 at x equal to 1. So you observe that the left hand derivative is 1, right hand derivative is 2, left hand derivative is 1, right hand derivative is 2, and hence left hand derivative is not equal to right hand derivative, and hence the function is not differentiable at x equal to 1. The function is not differentiable at, so the function is not differentiable at x equal to 1. Consider the function f of x equal to x minus 1 modulus of x minus 1 where x belongs to R is not differentiable at x equal to 1. So given function is f of x equal to x minus 1, f of 1 is 0, left hand derivative is minus 1, right hand derivative is 1. So both exist, but not equal, and hence the function is not differentiable at x equal to 1. The function is not differentiable at x equal to 1. Let f of x equal to 1 plus sin x, x is in between 0 and pi by 2, and 1, x is less than 0, show that f dash of 0 does not exist. Here you see that left hand derivative is 0, right hand derivative is 1. So the function is not differentiable because left hand derivative and right hand derivative are not equal. Left hand derivative is 0, right hand derivative is 1. So these are not equal, therefore the function is not differentiable at x equal to 0. So definition: the process of finding the derivative of the same function again and again and is called as successive differentiation, are higher order derivatives, and the result of such differentiation are called successive derivatives or higher order derivatives. The process of finding higher order derivatives is called successive differentiation. So if y is equal to f of x is a function of x, its derivatives are denoted by dy by dx, d square by dx square, dqy by dx cube, and so on, or f dash of x, f double dash of x, y dash, y double dash, y1, y2, y3, and so on, or dy, d square by, and hence so on. So this is called successive differentiation. So y is equal to log of cos x. Y is equal to log of cos x. Find d cube y by dx cube. So dy by dx equal to minus tan x. D square by dx square is equal to minus secant square x. Third derivative d cube y by dx cube is 2 minus 2 secant square x into tan x. So x equal to a into t minus sin t, y is equal to a into 1 plus cos t. Find d square by dx square. So this is x is given, y is given, dy by dt, dy by dx by dt, dx by dt is a into 1 minus cos t, dy by dt is a into sin t. Next dy by dx is dy by dt into dx by dy by dt into dt by dx. So on simplification we get minus cot of t by 2. Second derivative is d square by dx square. This is equal to 1 by 4 into cosecant to the power of 4 of t by 2. So this is a second derivative of the given function. If y is equal to x plus tan x, if y is equal to x plus tan x, show that the relation cos square x d square by d square minus 2y plus 2x equal to 0. So given function is y is equal to x plus tan x, dy by dx is 1 plus secant square x, d square by dx square is, this is 2 secant square x into tan x, then secant square x is becomes cos square x, so cos square x into d square by dx square minus 2y plus 2x equal to 0. If y is equal to sin of sin x, prove that d square by dx square plus tan x into dy by dx plus y into cos square x equal to 0. So y is equal to sin of sin x dy by dx equal to this one, d square by dx square is equal to minus dy by dx tan x minus y into cos square x, and then last step is d square by dx square plus tan x into dy by dx plus y into cos square x is equal to 0. Y is equal to e power x into sin bx. Prove that d square by dx square minus 2a dy by dx plus a square plus b square into y is equal to 0. So y is equal to e power x into sin bx dy by dx calculate ಮಾಡಬೇಕು. Next second derivative is this one. Third derivative is on simplification we got d square by dx square minus 2a dy by dx plus a square plus b square into y is equal to 0. So if x equal to a into cos theta plus theta sin theta, y is equal to a into sin theta minus theta cos theta, find second derivative. So given x equal to a into cos theta plus theta sin theta, y is equal to a into sin theta minus theta sin theta. So dy by dx is dy by d theta is a into theta into cos theta. Dy by d theta is a into theta into sin theta. Dy by dx is dy by d theta into d theta by dx. So on simplification we get tan theta. Second derivative is 1 by a theta into secant cube theta. So these are multiple choice questions. So thank you.